Okay, once again, welcome to our channel. So we have another topic sa integrants involving quadratic or linear and quadratic expressions. So generally, it looks like this. The given will contain any of the following. We have the integral of the square root of the quadratic function. We call that as f of x. Then we also have the integral of the dx over the square root of a quadratic function, f of x. So our quadratic expression here is generally called as f of x. Or we have the integral of a dx over f of x. So any of this form, no? So we have to take the same approach on how to integrate. So by completing the square method, especially when your quadratic has a first degree term, no? So you can reduce the f of x into sum or difference of two squares. So basically, I need to recall the completing the square method because I want to express my given f of x into a squared minus u squared or a squared plus or minus a squared through completing the square method. So if I have a perfect square trinomial, then I can also give a binomial square. So like when I have x squared plus kx, so if the coefficient of x squared is 1 and the next term is a first degree term, so to produce a perfect square trinomial, the third term must be half of the constant coefficient of the coefficient of the first degree term. So if my k here, or my constant coefficient here is k, so you divide your k by 2 and then you take the square. And this is now a perfect square trinomial where I can have a binomial square which is x alone and added with k over 2 and this is put into square. Perfect square trinomial is squared plus 2ab plus b squared. That's equal to a plus b or the square of a plus b. When this is minus, so it's also minus here in between. Okay? So example, just to familiarize on how to reduce or how to arrive with a perfect square trinomial and a binomial square. If this is the expression and then you are asked to give the third term to have a perfect square trinomial and then equivalently give the binomial square. Actually, if this is 1 exactly, then it can easily be provided with the third term. The third term is half of your k. Your k is equal to 6. So half of that is 3. So I must provide the third term which is 3 squared. So x squared plus 6x plus the square of 3. So you can have it as a binomial square by writing it as x plus 3. So kanaray mo gamiton. X and 3 here. The bases of the first and last term. No? Or their square roots, correct? So we can have the square of x plus 3. Second, if I have x squared minus 5x, so my k is negative 5. The half of k is negative 5 halves. So, what is the term to be inserted? I have x squared minus 5x, so the term is minus 5 halves. Then put that into square. And your binomial square is x lang dire. Actually, they're square roots. Diba? So, may butang diya. And then you have the binomial square. So, x minus 5 halves because this is negative 5. So, x minus 5 halves or the square of x minus 5 halves. So, ito i-apply ka ron dire. You are asked to evaluate. Wherein your given is this one. So, what is important there to note is that there is a second degree term and a first degree term. The third term may be there or not. So, the third term must be separated this way. So, x squared minus 2x. So, I have my third term placed there. And I'll be looking for a term to be inserted following the pattern ganina. This is my k, which is minus 2. What is half of k? It's minus 1. So, I'm adding a negative 1 squared. Or I'm adding 1, correct? But if I'm going to add a term in an expression to neutralize, I also have to subtract the same term. So, I have a negative of minus 1 squared. So, this is a perfect square trinomial. So, a term being subtracted will also be associated with the constant term. So, we have x squared minus 2x plus the square of minus 1 wherein you can write that as x minus 1 squared. This is the binomial square of the perfect square trinomial. 15 minus 1 will give you 9. So this is now taking a form of u squared plus a squared. And if your u is x minus 1, so the formula to be used is kine. So I need a u du form. So if my u is x minus 1, the du is dx. So meaning, I can apply the formula directly. In the formula, I need an a. So I have the square root of 9, which is my a. The formula is used. I have 1 over a. So 1 over 3. Arctan of your u, x minus 1 over 3 plus c. So this is how to reduce or to arrive with the answer when ang atong given involves a quadratic expression, especially when that contains a first degree term. Wherein, ato siyang ibutang into sum or difference of 2 square by completing the square method. So dali ra siya kung ang coefficient of your second degree term is 1. While here, there is a little problem because the coefficient of x squared is minus 1. But it can be reduced to 1 by, factoring out a negative 1 because I cannot divide it. Okay, so ato lang i-factor out ang negative 1 because I cannot put that outside this expression because of the radical symbol. No? So factoring out ang negative 1, x squared plus 6x. So leave a space to insert a term. Copy 7, but 7 also becomes opposite. So minus 7. So, what is the term to be inserted when we have k which is equal to 6? So, half of that is 3. 3 squared, correct? Perfect square trinomial. You are adding 3 squared. So, para ma-neutralize, if I have positive 3 squared, I also have a negative 3 squared. What's their sum? That is 0. So, if you are adding 0 to the expression, so, you are not actually changing the whole expression. Your only interest is to arrive with a perfect square trinomial there. Okay, so I have the square of this, x plus 3, their sum is pila? Minus 7 and minus 9, so you have minus 16. The negative 1 being factored out, I cannot take the square root of negative 1 separately with this. So, that is why I can redistribute my negative 1 factor. So, 16 becomes positive, then this becomes a negative. So, it is now taking a form of a squared minus u squared. The square root of that, correct? So, there is a formula that can be used, and that is the I-18, correct? So, my dx is the du. So, when I am going to differentiate that one, so my a is 4. So, I can have the I-18. So, it's arc sign. So, because there is a u du form, there is a u and a du form, so I can go with the formula I-18. So, it's an arc sign of x over 3, x plus 3, over 4. Then, plus c as our answer. Okay, so that's a sample on how to arrive with some difference of 2 square. Now, okay, one more. Actually, here, because x squared has a coefficient which is not 1, that is 9, you can also factor out 9. So, dire, pwede kayo ka mag-factor out of 9 and then you can take the square root of 9. Pero, this is based for you to consider. If the first term is a perfect square, if you take the square root of that, there is an integer constant coefficient, no? With x, no? So, that is a perfect square. We can look for a term to be there to produce a perfect square trinomial directly by applying this formula. A squared plus 2ab, I'll be looking for the third term, which is the b squared or your b. Just let your first term be your a squared. The second term be your 2ab, and I'll be looking for my b squared or my b. Because if that follows this, then you can easily go with the square of a binomial. Okay? What is my a? My a is equal to 3x because my e squared is my first term, correct? My 2ab is the second term, that is 6x. So if I'm going to solve for b from this equation, then ako siyang i-divide with 2a. Both sides, no? This can be b when I'm dividing this by 2a. However, my a is known to be 3x. So, I can solve for b by replacing, no? Ang 6x, niya to, ang a, ako himon 3x. So, if you divide, ang imo di b must be equal to 1. So, what does it mean? So, you can have, kine, the square root of 9x squared plus 6x, you add your 1, but you take it as square because that is b squared. This is b only. But hinoon, 1 squared is still 1. You are adding 1. Kung saan mo pag-neutralize, you also have to subtract. So if you add, you also have to subtract the same term. This becomes a perfect square trinomial by adding a 1 squared, but this is inserted to neutralize the effect of the expression being inserted to the expression. So we group this constant 3 minus 3 will be associated with the minus 1 squared. So this becomes minus 4. The perfect square trinomial can now be written as 3x plus 1, the square root, their square roots. So square minus 4. So kini siya tanan, actually maura gini siya. Our u, before the formula will be used, is 3x plus 1. The du is 3dx. So meaning, ang ato karong given is lacking a constant factor of 3. And we can neutralize with 1/3. And I can apply the formula which is this one. So we have u over 2, the square root of the given, or the given itself. So we have 1 over 3. What is our u? Kini. Divide by 2. Then the square root of, take this expression, then it's minus, according to this, if that's minus, minus na di mo gamitan. So I have minus, 4 over 2 is actually a squared. A squared, this is a squared. Correct? Do not take the square of 4 anymore because this is a squared already. Our a is 2 man, di ba? Okay. So 4 over 2, according to formula. Okay, so ln, your u is copied, then plus. I take the same, given, okay, then plus c. When 1/3 is distributed, I have 1 over 6. Correct? This is minus 2 divided by 3. Okay, now this one, if I'm going to expand and combine the terms, then you will go back to the given. Maura mo na siya. Okay, so minus 2/3, ln of 3x plus 1, then plus. Okay, again, that is reduced to the original expression which is kana. So this is our answer. And that is our number 3. So, if the first term is a perfect square, so kanila ay pattern gamita. Actually, this is also an explanation why if we have k squared or x squared plus kx, then we will be adding k over 2. Actually, it follows the same pattern as this. No? So, maura gini siya. Okay? So, next, the given may contain also a form containing linear, and linear is represented with a general expression g sub x. So, it may contain a linear together with a quadratic. So, either square root of f of x or square root of the quadratic, then dx, then or pwede sa integral of a linear over the quadratic functions. Okay? So, saan na to pag-integrate? To solve, you start with the quadratic function, f of x. Call your f of x as u. Then immediately solve its du. Then develop a trick in reducing the given so that the standard integration formula can be applied by letting our linear g sub x to follow the du of the quadratic functions. Okay, so here is an example. I have the integral where the numerator is a linear function, so your variable is involving a power 1. Your denominator is in quadratic form. So, doon na ganit linear, doon na quadratic. So, do not call this as a squared minus u squared, but start right away calling the whole quadratic as our u. We let our u be equal to pila? 25 minus 16x squared. What's the du? It's minus 32 x dx. Okay? So, the du is only containing a term involving x. So, constant may not be necessary here. So, what if I'm going to develop a trick, I have to separate this into two terms with the common denominator which is kini. Okay, so I can rewrite as that. So, 3x over the 25 minus 16x squared, then minus it over the same denominator. My first term, so I can put my 3 diha, leaving an x with a dx in my first term. Okay, but using the du form, this is lacking with minus 32, I can neutralize with 1 over or minus 1 over 32 dere. 3 is from the given. I have the negative 8 and I have to use a formula, kine, When this is purely quadratic, wala na first degree, or wala na variable ng power 1, so pwede na ninako tawgon og e squared, kana mo u squared. So what is my u? The square root of 16x squared, it's 4x. The du is 4dx. My a is 5. And I can relate that with the formula I22. So, du over yun kini this is I22. So, 2, correct? 8 over 4. So, using your 22, I22, so 1 over 2a, correct? Are you following? ln of a plus u over a minus u. Okay? So, this is now your final answer. So, linear atong ipahiluna nga mo follow siya sa du form of our quadratic. Okay? So, next. Dali-dali rin siya nga naman, wala may first degree term dere. Kaya naa pa, mag-apply sa ga og completing the square method. Okay, so next is, mao na ni siya, doon na first degree term. So, medyo dugay-dugay ni gamay. So, if there's a linear here, so you can start calling your quadratic totally as your u. So, if my u is, kana, the given, x squared minus 4x plus 5, my du is 2x minus 4. Correct? So, okay. I have to look at my given. Good. That my given is also containing 2x. So, dali ra kay na may 2x. So, to have an exact du, 2x will be followed with a negative 4. So, if I'm going to insert a negative 4 here in my given, so I also have to neutralize by adding positive 4. Okay, so, here I have 2x minus 4, based on this, originally I have plus 9, the new one is the negative 4. So, I'm adding a negative or I'm inserting a negative 4. I can also neutralize by inserting a positive 4 to make their sum be equal to 0. Okay. So, group kana over its denominator, their sum over the same denominator. So, integrate this way. We have what's that? 2x minus 4 dx over kana. This is du over u. So, its integral is this one. So, in I5, you can also use an absolute value bar. No? Kine, this is quadratic. There's a first degree. So, you can apply completing the square. Good, it is 1 dire. So, I can identify the constant to be inserted, which is half ini. Minus 2, I take the square. I'm adding 4 here. Diba? 4 man So, I can subtract also 4 dire. Okay, now, what is the result? X minus 2 squared out from this. Diba? Binomial square man niya. And what is 5 minus 4? It's 1. So, this is u squared plus e squared. A is 1. Your u is x minus 2. The du is dx. So, meaning, there is already a u squared du form with your a equal to 1. So, ln of that function, 13, 1 over a, but that is 1. So, arctan of u over 1, no? X minus 2 over 1. So, your final answer is just good as that. Next is this one. Okay? So, x squared has a constant coefficient of 4. 4x squared is a perfect square. So, instead of removing a negative 4 by factoring, ako na lang igawas ang negative 1 factor. But before that, dili na pwede akong idiritso. Nga naman, nagalimot ko. So, hatagig chance ang tiguang, nagalimot, no? Okay. So, I have to call this entirely as our u because there is a linear expression involved, no? So, what is my du? That is 12 minus 8x dx, correct? Now, if I'm going to remove my 8 so that I can start with x dire, divide every term by 8 or minus 8, so I can start with x. So, 12 divided by minus 8, so you have minus 3 halves. Now, di man good pariho ganina that if this is 2x dire, 2x na nagasugod. So, if this is x, that is 8x dire, kanto 3x, correct? So, instead, ang akong gigawas kining minus 8, ang ako sa nisang pagawson nga doon lalay coefficient nga 1 by factoring out 3 para all will start with x. Anyway, constant factor, kung di na ko apilon, we can always insert a lacking constant factor. So, if I'm factoring out a negative gikan dire, kire mag-factor sa ko og unsa? 3. Okay, so I do it this way. 3 by factoring out dire so that I can start with x, pareho dire. Okay, so this is my manipulation. This is my trick I did. Okay, so putting my constant 3, I have x minus 3 halves. My 3 halves is based on this. I did not include it because it can be inserted later. So, x minus 3 halves, I have minus 4/3 from the given, no, by factoring out 3. So, I'm adding 3 halves because I'm inserting a negative 3 halves, sir. Okay, what is their sum? Kana. That is 1/6. Then, this can be x minus 3 halves. I group them. Over the same denominator, kana over the same denominator. Okay, so how do I continue arranging them? Okay. I group them. X minus 3 halves over the same denominator. Then, how come I have 1 half here? It becomes 1 half because 3 is also distributed on the second term of 1/6. So, that means my 3 is already distributed there. So, I have 1 half. And I have a dx with pure quadratic function. Here, para mahimo siyang UDU form, so I have to insert the lacking constant of minus 8. Ako gibanag minus 8, gineutralize na ko minus 1/8. So, mo nang dunay minus 3/8. Dire, I factored out the negative 1. So that, ang 4 di lang ako apilon because that is a perfect square, correct? So, it is 4x squared minus 12x, distansyang 5 because I need to insert a term here. So, dali ra ni siya. So, karon nga nahibaw na ta nga kini siya maoy akong i-divide og 2a. So, 12x minus 12x divided by 2 and the square root of my first term. So, there I have a negative 3. So, negative 3 will be inserted by addition and minus 3 there is used to neutralize. Okay? What is your binomial square? Here I have. Okay, ako lang nang i-copy. So, okay na ni atong UDU form, U and a DU, pero kana may DU, pero dili sa ni siya may U, kay doon na may exponent diri nga 1/2 in the denominator. While here, I have negative, this is my binomial square. I have the difference, pila man eh? 5 minus 9 is negative 4. But, doon na may negative 1 factor here. So, I have to distribute again 4 minus kana. May U is 2x minus 3. Makalimot ka nga nanginanglan kag D which is 2 dx. So, kuwangag to neutralize with 1/2. Okay? I can further rearrange. To use a power rule, this is containing an exponent of 1/2 ato isaka. So, negative 1/2. This is group as a DU. U to a power negative 1/2 and a DU, dx, correct? Then this becomes, asa man eh, this is 1/2. Ang 1/2 is inserted because of this. Okay? Then I can have the integral, adding 1/2 over 1/2. So this is now the result. Minus 3/4. So, power rule plus 1/4, correct? Arc sign of, okay, 2x minus 3 over 2 plus c as our answer. Okay, so that's how to manipulate to arrive with an integrable form when it contains linear and quadratic. But maybe you are confused on how to reduce this one, no? But if it's okay for you, so the better, no? Now, I'm going to introduce a little technique on how to arrange them systematically this way. So, I have another solution for number 3. This is my given. I take the same given. Okay? Now, I want to rewrite my linear function in the given to be the same as the DO when I try to evaluate the DO of my quadratic, which is kine. And that is 12 minus 8x. Now, immediately, I have to copy this in my numerator side as this one. 12 minus 8x, and I have to put an unknown constant a here where I have to determine this later. So I have my A diha, which is multiplied to the DU, then plus B. Because B over this is the pure quadratic denominator, and this is linear, and it's DU, and it's U. So U and its derivative, correct? So, how to solve for this constant A and B? Now, take note, this numerator here is the same as the numerator in the original ratio. That would mean 3x minus 4 is just equal to A times the quantity 12 minus 8x plus B. Okay, sundan lang na siya, ha? Kung sa imong gibuhat, ato lang gisolve on sa iyang DO, atong giplaster diha diretso. But akong gibutangan og unknown A and B. And we will be solving for A and B. Okay? So, my numerator here is the same as the given. So, 3x minus 4 is equal to A with kana, then plus B. I want to solve for A and B. I can distribute 12A minus pila, 8A x term plus B. So, solving for A and B by equating coefficients of similar terms. No? So, kasikit-sikit na, no? So, solving for A and B by equating coefficients of similar terms. Like x terms, no? X raman ni term. Correct? So, ang atong x term dire is kini. The x term is having 3 at the left. Correct? Na ako'y x term where the coefficient is 3 at the left side, which is that one. I copy that one. Which is equal to an x term which is found at the right. Mura man x term. The coefficient of that is minus 8a. Correct? So I can solve for a right here. What is my a? So out from this equation, you divide 3 by minus 8. So I have minus 3/8. Now I have a constant term here at the left which is negative 4. And my constant term at the right, constant man ni variable x. Kopyahon na nimo. 12a plus b. So, if my a is 3 over 8, correct? Kung kana siya 3 over 8, then I can have my b. So, minus 4 is equal to 12 times pila? 3 over 8. Okay? Then, that is equal to b equal to 12. By the way, mahimo sa nag-imong kalkyuhon in the system of two unknowns kana. No? Pero kana, pwede na nato ma-substitute, no? Araban na ko mabutang ang substitution. I hope you can follow, no? So, this one. After solving for a which is minus 3/8, so you substitute here, minus 4 equal to 12 times minus 3/8, then you solve for b. No? So, it is 4 negative, then added with 12 times 3 over 8, you combine, so your b will come out as 1/2. No? Nadiritso ni nako because I am assuming that a calculator will be used to solve for a system of linear equation in two unknowns. Pwede masad ni makalkyo. Pareha nang doon na kay xy terms, then constant. No? So, pwede na makalkyo. Pero, you can also substitute your a here, and then you can solve for b there. Okay, so after knowing that, so I can go back here. My term is containing a. What is my a? 3 over 8. So, put your minus 3 over 8 there. Leave your du form in the numerator. So, it is 12x minus 8 together with the dx. I have b which is 1/2. So, 1/2 is placed outside and I have the integral of a dx with the same denominator. I go with the same process. So, I use this, expressing this to have a power of negative 1/2. Onya kini, I tried to apply completing the square method by removing a negative 1 factor. So, 4x squared minus 12x. Inserting, o siya akong insert, minus 12x divided by 2 times 2x. And the result is minus 3. Take that into square and adding a term which is 9. I can also subtract 9 also. So, there I have an integrable term like this. We have this one. Okay. So, I'm inserting 2 because my u is 2x minus 3. So, gire, ato nang gibutang as a binomial square and it was interchanged, no? So, doon na naman tayo paringan ako na lang gidiritso, So, we have actually 2x minus 3, then minus 4. And negative 1 is distributed, so that is why we have 4 minus 2x minus 3 squared in my second term. A squared minus u squared, so that is the arc sine of u over a. But before that, there must be a constant to because this is your unsa, u, and that's the du. That's 1/4. Okay? So we have 1/4 arc sine of 2x minus 3, the second term. Kine, nahimong 1/2 kay nga naman, this is added with 1. And that's 1/2. The in plus 1, ibutang sa nimo dire. And then we can have the minus, no? We have the constant. Then that as your final answer, no? So I hope everything is clear to you and you were able to follow. Okay, so thank you for watching and I hope this is helpful to you. Okay, I hope you were able to understand this part. So it is simply equating coefficients of terms which are actually similar. So kung x term, ari sa x term sa left, kuha ang say constant. No? So diha mo rin magduda ko basig wa nimo masunod. This is my x term. So the coefficient is minus 8a. So minus 8a is equated to the coefficient of x at the right. Okay? So my a is solved. And then, sa atong constant term, I have 12a plus b. Wala man ay x. Ari sa gas term dari nga wala x, which is negative 4. After knowing your a, then your b is there. Okay? So, that's the process. And I hope everything is okay. So, feel free to ask if in case you have some doubts wherein you cannot follow. So, butang last comment siguro, no? Para maligri ato ang YouTube sa inyong comment, no? Okay, so that's all and have a good day.